Good evening, everyone. Welcome back. Today is our fourth session, and let's quickly revise what we discussed in the last session. In the last session, we discussed about what is a software project, why we need to develop software project, what types of software projects are there in the market, and what is the architecture of a software project, and what are the technologies are available to develop software projects. Okay, good, fine. Now, here, if we discuss that software project is nothing but collection of software programs. Collection of software programs is called as software project. To develop software programs, we will use software programming languages. There are several programming languages available in the market, like C, Java, Python, C#, PHP, etc. We can use any one of the language in order to develop our software applications. Good. First of all, why we need to develop these software applications? Software applications are used to reduce human efforts and simplify humans' life. So we have seen IRCTC tickets booking, Google Pay, Phone Pay for the net banking operations, Amazon, Flipkart for online shopping, okay, Book My Show for booking the movie tickets, Swiggy and Zomato for the food orders. All these applications are simplifying human life and they are reducing the human efforts. And in the IT industry, there are so many projects are available. So all those projects we can categorize into four types. First one is called standalone application. Second one is called web application. Third one is called as distributed application. And fourth one is called mobile application. Standalone application, nothing but the application which will execute in only one system. So like a calculator, notepad, etc. Web application means multiple users access those applications at a time. Gmail, YouTube, Facebook, etc. And distributed applications also available in the market. Distributed application, nothing but if one project is communicating with the another project, then those projects are called as distributed projects. Okay, here they are also called as web services, guys. Distributed projects are also called as web services. The next one, mobile applications are available. Mobile applications, nothing but the applications which we are going to install in the mobile for accessing them. Nowadays, some projects are available for both the web as well as for the mobile also, like Facebook. You can install Facebook app in the mobile. You can use Facebook in the browser also. Similarly, Instagram. You can install Insta app in the mobile and you can use Instagram in the browser also. Like this, nowadays in the market, some projects are available for both. Okay, next one. What is application architecture? As discussed yesterday, in our project, mainly three parts will be available. First one is called front end of the application. Second one is called back end of the application. Third one is called database of the application. Front end, nothing but user interface, guys. So here, end users can see whatever the users can see on the application, that is called front end of the application. So this front end is called user interface. We can also say that front end, nothing but presentation logic. Okay. Now, in order to develop this front end, there are several technologies available in the market. Like nowadays in the market, people are using Angular or React in order to develop front end of the application. And next one, when user perform some operations in the front end, like clicking a button or something, then it is going to communicate with back end of the application. Okay. Now in the back end, business logic will be available. So user credentials are valid or not. Inside the user record, when the user is registered in the application, inside that user record, such kind of backend operations will be available. So to develop that backend, there are some technologies like Java, Python, .NET, etc. The backend application will communicate with the database to store the data permanently. So we are going to perform CRUD operations, create the record, update the record, delete the record, retrieve the record, like that. CRUD operations we are going to perform in the application. So there are several types of databases available in the market like Oracle, MySQL, SQL Server, MongoDB, and Cassandra. So this is called application architecture. If you go for any project, this architecture is common, guys. Then what is the tech stack of the application? Tech stack, nothing but what technologies are used to develop that application. So as we discussed, there are several technologies available for front end, several technologies available for the back end. Okay, several databases also available in the market. So people can use any combination to develop the project. Okay, project to project, company to company, that a technology stack also going to be different. Okay, good. Next one. In the real time, people will develop the application in two ways. One is called as monolithic architecture, and the second one is called as microservices architecture. So people are going to develop the application in two styles. Those are called architectural patterns. Those are called architectural patterns, right? Monolithic architecture and microservices architecture. Let's understand what is monolith architecture, why people are going for microservices architecture. Okay, what is monolithic architecture? Now, if all the requirements developed in single application, then it is called as monolithic architecture. So develop, if we develop all functionalities in one single application, then it is called as monolithic architecture project. Are you guys getting my point? What is monolithic architecture? If we develop all functionalities in the project, so we are working for a project. Suppose, for example, if you take a banking application, so if we develop all the bank related functionalities in one single project, then it is called as monolithic architecture. Now, so if you see, monolithic architecture means one big application which contains everything. One big application which contains everything. So diagrammatically, so if you represent like this. So in my project, I have functionalities like there is a net banking functionality is available, and there is credit card related functionality is available, and there is debit card related functionality is available. There is loans related functionality is available. And some mortgage or reports functionality is available. So like this, there are several functionalities available. If we develop all these functionalities in one single project, guys. So like this, I'm going to develop one project. So if you develop a project like this, then the project is called as a monolithic architecture project. Everything is available at one place. If you develop a project like this, then what is the problem? There are so many problems available if you develop a project like this. That means if you develop a project using monolithic architecture, if you develop a project by using this monolithic architecture, there are some drawbacks available. What are the drawbacks available if you develop this? Okay, so everything at one place. All the functionalities available at one place. Now tomorrow, if there is a small problem in the debit card functionality, then the entire application is going to be down. So there is a chance for single point of failure. So when you go for monolithic application, there is a chance for single point of failure. Single point of failure is available. What is the meaning of single point of failure? If there is a small problem, then the entire application is going to be down. Single point of failure, nothing but. So there are different functionalities available in our application like net banking, credit card, debit card, loans, reports. So everything is available in one project. If a small problem occurred in that project, then the whole project is going to be down. Single point of failure will be available. And another problem, as everything is available in one application, some people are using net banking, some people are using credit card, some people are using debit card, some people applying for the loans. But all the user requests will go to one single server. That's why the burden will increase on the server. That means burden on server. So when you go for this monolithic application, so many functionalities are there in the application. So many functionalities are there in the application, but all those functionalities available in the single application, as all the functionalities available in the single application, all the user requests will go to single application. If all the user requests are going to single application, burden will be increased on the server. Burden will be increased on the server. So here, maintenance is difficult. Maintenance of the project is difficult. Okay, so if there is a small change, then we need to redeploy the entire application. Now, I have made some code changes related to debit card functionality. So if you make the code changes related to debit card functionality, you need to redeploy the entire application again. Okay, the whole project should be deployed again in the server. Redeployment is required. So whole project we need to redeploy. Redeploy entire application. Okay, redeploy entire application. So again, we need to take the latest code from the project and we need to compile that project and we need to redeploy entire application. So these are the challenges available when we go for monolithic architecture. What is the meaning of monolithic architecture? If we develop all functionalities in one single application, then it is called as monolithic architecture. So with the we have several drawbacks with monolithic architecture. We have several drawbacks with a monolithic architecture. We have several drawbacks with monolithic architecture. So what are the drawbacks available with this monolithic architecture? As we discussed, everything will be available at one place. That means all functionalities available at one place. If there is a small problem, the entire project will be failed. Single point of failure will be available. As everything is available in one server, multiple user requests are going to a single server, then burden will be increased on the server, then responses will be slowed down. And as everything is there at one place, the maintenance of the project is going to become very difficult. And if there is a small change in the application, then we need to redeploy the entire application. We need to redeploy the entire application. To overcome these challenges to overcome these problems, to overcome these drawbacks, people are using microservices architecture. To overcome these drawbacks, people are using microservices architecture. Are you guys getting my point? Now, what is the meaning of microservices architecture? Microservices nothing but small independently deployable services. Microservices nothing but small service. Micro means small services. So instead of developing everything in one application, we are going to develop application as small services. So how this microservices development will happen? So here for the net banking, we are going to develop one separate project, guys. So we don't include everything in one project. So here net banking will be developed as separate project. Credit card operations will be developed as separate application. And loans will be developed as separate application. Okay. And here reports of our application developed as separate application. Net banking is one independent project. And here credit cards operations are one independent project. Loan related functionality available in one independent project. And reports available in one independent project. Okay. So this project will have its own database. Okay. Net banking will have one database. Credit card is having one database. Loans having one database. Reports having one database. So these all are related to bank only. But in the bank, several functionalities are available. Instead of developing all these functionalities in one application, we are going to divide these functionalities into multiple APIs. What is the meaning of a multiple API? Every API is a separate project. So what is the meaning of API? Every API is independently executable and every API is independently deployable. So these APIs are loosely coupled. These APIs are loosely coupled. For all these APIs, UI application will be separate. One separate UI front-end application will be available, and in the back end, multiple APIs will be available. When user access UI application will communicate with these back-end applications, depends on the requirement. UI application is going to communicate with back-end application. Now, here UI application is available. That UI application is going to communicate with the backend applications. So here, when we develop our application like this, what is the advantage, guys? Can you see any advantage if you develop our applications like this? So these are called microservices. These are called microservices. Earlier, we developed one application which is called monolithic application. Monolithic application, nothing but everything is available at one place only. One single database will be available. All these functionalities will be available in one single application. One single database will be available. Maintenance of the project will become difficult when you go for monolithic application. Okay. Now, if you don't want to go with that monolithic application, then the alternate for us is microservices application. So what is the meaning of this microservices? Microservices nothing but independently deployable applications. Net banking functionality. Instead of developing everything in one application, whatever the requirement is available for the net banking, only the net banking related functionality will be available in one project. So this is called as net banking API. For the credit card related functionalities, we will develop one separate project called credit API. So net banking API contains only net banking operations. Credit card project contains only credit card operations. Loans project contains only loan operations. Reports API contains only reports functionality. All these four functionalities developed as four separate independent projects. So tomorrow, when there is a problem in the net banking application, is there any effect on these three applications, guys? If net banking functionality is not working, is there any effect on the other three functionalities? No effect on the other three functionalities. If net banking functionality is failed due to some problem, is there any effect on the other three functionalities? There is no effect on the other three functionalities. Why? Because these four projects are independently deployable and independently executable. These projects are independently deployable and independently executable. So these four projects are loosely coupled. So this project, if it is failing, only that functionality will be down. The remaining functionalities will be available for the users to access. Tomorrow, if there is any code change required for the loans, I want to make some code change. If I make some code change to the loans application, do I need to redeploy these applications also, or we need to redeploy only this loans application? If any change happened in the loans project, do we need to deploy only the loans project, or we need to deploy all the remaining three projects also? We need to deploy only loans project, or we need to deploy all the other projects also? We need to redeploy only the loans project. We no need to redeploy all the other projects because these projects are independent. Got my point? Now, so there are multiple users are using our bank application. So the people who are using net banking, their request will go to net banking server. Some people are using credit card operations, their request will go to credit card application server. So net banking application will run in one server. Okay. Credit card application run in one server. Loans application runs in one server. Reports application runs in one server. Now, all the users who are doing the operations in our bank, all the user requests are going to one single server. The user requests are distributed to 4 servers, guys. Is everything available in one server? The functionality is also distributed now. Is everything available in one server? The functionality is also distributed now. The functionalities also distributed now. The functionalities are distributed now. Are you getting my point? So the burden will be reduced on the server. The burden will be reduced on the server. Are you able to follow me? Are you able to follow me? So if you develop this application with microservices architecture like this, the burden will be reduced on the servers. When you go for monolithic architecture, everything is available at one server. All the requests will go to single server. Then burden will be increased on the server. But when we go for microservices architecture, functionalities are distributed. So the multiple servers are executing multiple backend APIs. The requests also will be distributed. So high availability will be there for our application. Now, tomorrow, if any code change is required for the net banking application, do I need to bother about the remaining APIs? If any code change is required for the net banking functionality, is there any effect on the remaining APIs? There will not be any effect on the remaining APIs, guys. There will not be any effect on the remaining APIs. So this is microservices architecture. So microservices nothing but small services which are independently deployable and executable APIs. Okay, small services which are independently deployable and executable. Every microservice is having its own functionality. Every microservice is responsible for its own functionality or one functionality. So every microservice will have limited functionality. Everything we don't develop in one project. Every microservice will have limited functionality. The project contains multiple microservices. In one application, we can have several microservices. So what are the benefits with the microservices? We have below advantages with microservices. What are the advantages? First one, loosely coupled. So the first one is loosely coupled. Right, guys. So what are the advantages with the microservices? Loosely coupled. What is the meaning of loosely coupled? Every microservice is independent, guys. Every microservice is independent. Okay. So these microservices are loosely coupled, independently deployable, and independently executable. Loosely coupled. And high availability. So there is no single point of failure. Even if one microservice is failed in the application, only that functionality will not be accessible for the users, but still the other functionalities they can access in our application. High availability will be there for our application. And no need to redeploy all the APIs. When there is a code change, we no need to redeploy all the APIs. You get my point? Redeployment is not required for all APIs. No need to redeploy all APIs. For code change, when there is a code change, no need to redeploy all APIs. If there is a small change, if there is a small change in one API, so we need to work on only that API. We no need to bother about all the APIs which are available. No need to redeploy all the APIs. Okay. And technology independence. When you go for microservices, technology independence will be available. Nothing but there is no rule that all the microservices, all the APIs should be developed by using one language. For this project, I will use Java. In my company, .NET developers are free. I can ask them to develop one API. This project I can develop by using Python. This project I will develop by using Node.js. So if you go for monolithic application, one single project available, you need to stick to only one technology. Everything should be developed by using only one technology when you go for monolithic architecture. But when you go for microservices architecture, you no need to, there is no force that you need to use only one technology. If you want to use multiple technologies for your application, then you can develop every API with a different technology. There is no problem. There is no problem. So net banking application, that is one project, it will run in one server. That is one project, it will run in one server that will be developed by using Java. And when you go for credit card application, that is a separate project, you can develop by using separate language. Backend, these applications are backend applications. These are backend microservices. So these backend microservices are independently deployable and independently executable. Independently deployable and independently executable. If there is a code change of one microservice, then you no need to redeploy all the microservices. Okay, guys. If there is a change in one microservice, then you need to redeploy only that microservice. You no need to redeploy all the APIs. And all the user requests will not go to one server because every API will run in separate server. User requests also will be distributed. Burden will be reduced on the servers. Burden will be reduced on the servers. Are you guys able to understand? Are you guys able to understand what is the difference between monolithic architecture and microservices architecture? Are you guys able to understand the difference between monolithic architecture and microservices architecture? Yes, every microservice can have its own database. It depends on the requirement, guys. Every microservice will have its own database, or multiple microservices can use the same database. It depends on the project requirement. Some microservices will have its own database. Some microservices will use common database. It depends on the project requirement. It depends on the project requirement. Okay. So at infrastructure level, these are little expensive, guys, because instead of one machine, instead of running in one server, we are going to run these APIs in multiple servers, right? Infrastructure wise, these are costly, but maintenance wise, performance wise, maintenance wise, availability wise, these are best in the market. Infrastructure wise, we need to spend some amount to maintain the infrastructure to run our microservices application. Monolithic means only one project you can execute, but microservices means collection of backend APIs will be available and front-end application will be available. Okay, let us see any diagram, the internet, which represents monolith versus microservices. Monolith versus microservices architecture. Yeah. Let me take this diagram. Guys, can you see this diagram now? Monolithic versus microservices. Can you see this diagram? Monolithic versus microservices architecture. Monolithic, nothing but what they are representing. Everything in one application, user interface, business logic, database, everything at one place. But in the microservices architecture, multiple small services available. Okay. Every service is independently deployable and every service is independently executable. Independently deployable and independently executable. Let's look at this diagram now. Look at this now. Monolithic architecture versus microservice architecture. In the monolithic architecture, user interface, business logic, data access layer, everything is available at one place, and that application is communicating with one database. That application is communicating with only one database. Now, coming to microservices, the functionalities are divided into small services. Every microservice is a separate project. Now, if you take an example of Make My Trip application, if you go to Make My Trip application now, what you can see in the Make My Trip application? What you can see in the Make My Trip application? In the Make My Trip application, flights booking is available, hotels booking is available, trains booking available, bus ticket booking available, cabs booking available, villa booking is also available, holiday packages available. So do you think that this application developed as monolithic? This Make My Trip, there are several different functionalities available. Flight tickets booking, hotels booking, holiday package booking, trains, buses, cabs. Do you think that they developed everything in one single application? Do you think that they developed everything in one single application? No. So if they develop everything in one single application, that is a problem, right? If there is a code change in the flights booking, they need to redeploy the entire application. If there is a problem in the trains booking, the whole application will be down. 100% this project is microservices project. But for end user, this is one project. Make My Trip is one application. But in the background, multiple microservices will execute. Flight tickets booking logic will be available in one microservice. Train tickets booking logic will be available in one microservice. Cab booking logic will be available in one microservice. Hotel booking logic will be available in one microservice. Tomorrow, if any code change is required for flights booking, only that project we are going to redeploy. We no need to touch the remaining projects available in the application. Okay. And all these microservices are only backend, nothing but which contains only business logic. For all these backend APIs, front end will be available in the separate project. End user will communicate with the front end application. When they perform some operation in the front end, then it is going to communicate with the backend. Backend application will communicate with the database. So here, every microservice will have separate database. All microservices will have single database. That is depends on the project requirement. That is depends on the project requirement. Are you guys able to follow me? Are you guys able to follow me, guys? Come on. Good. So monolith and microservices. What are the advantages with the microservices? The microservices are loosely coupled. For the microservices, high availability will be available. We no need to redeploy all the APIs for code change in one API. And technology independence will be available. So here, when there are multiple microservices, do we need to develop all these every microservice is a separate project, will run in the separate server. Every microservice is a separate project, will run in the separate server. Okay, so do we need to develop all these microservices by using, do we need to run all these microservices? Do we need to develop all these microservices by using one single technology? Do we need to develop all these microservices using single technology? Is there any rule like that? No, because every microservice is a separate project, will run in the separate server, can be used any technology for. Okay, so more flexibility will be available in the application when we go for microservices architecture. We will have more flexibility when we go for microservices architecture. Are you able to follow me? Good. Perfect. Now, what is the current trend in the market, guys, to develop the application? Monolithic architecture was outdated. It is outdated in the market. Earlier, long back, people used it to develop the project by using monolithic architecture. Now, people are developing the application by using microservices architecture. Every microservice we are going to execute as a Docker container. So every microservice now, why this Docker Kubernetes became very popular? The reason is microservices only. So because one in the real time, one project may contain 50 microservices, 100 microservices also. Executing 100 microservices is not easy task for the operations team. So when the applications were developed by using monolithic architecture, only one project will be available. Deploying one application is very easy. But today, microservices available. Microservice means everything is a separate project. So operations team demand increased in the market because of this microservices architecture only. Earlier, only one single application will be available. Only one single application will be available. So one person can manage these operations, deploying the application. But nowadays, so hundreds of microservices will be available in one application. So development time and operations development team roles, operations team roles got increased, and the demand is increased for the operations team because in the market people are developing microservices. For every microservice, separate build and deployment process will be available. Earlier, one project, one build and deployment mechanism is sufficient. But today, so hundreds of microservices available. For every microservice, different build and deployment mechanism is required. So that's why more operations team members are required to manage this application infrastructure, application builds, application deployments, application monitor. You got the clarity? Yes, perfect. Good. So I hope with this we understood theoretically related to software project. Okay. So we learned what is a software project. We learned what is software project. Now, Software project, nothing but collection of programs. And we discussed why software project. Software project is used to reduce human efforts. Types of software projects. We discussed about types of software projects. Standalone projects, web application, standalone application, distributed application, mobile application is available. Then next one, we discussed about application architecture. Okay. Every application will have front end, back end, and database. Front end means user interface. The presentation logic will be available. Back end means business logic will be available. And database is used for storing the data. Technology stack, application tech stack. Okay, application tech stack will be available. So what are the technologies we are going to use to develop the front end, to develop the back end? What are the databases available in the market? These all are tech stack of the application. Okay, then we discussed about monolithic architecture. We discussed about monolithic architecture. So if you develop everything in one application, which is called monolithic architecture, there are several drawbacks available with the monolithic architecture. Maintenance will become difficult and burden will increase on the server. Whatever the technology we choose, with the same technology, we need to complete the entire application. If any small code change is done, then whole application we need to redeploy. And if there is any small problem, the whole application is going to be down. So to overcome the challenges with the monolithic architecture, we are going for microservices architecture. To overcome the challenges of the monolithic architecture, we are going for microservices architecture. What is the meaning of microservices? Microservices nothing but collection of backend services, collection of backend projects. Instead of developing one project with everything, we will develop multiple microservices, small services we are going to build. Every microservice is responsible for one functionality, and those microservices are independently deployable and independently executable. Okay, so the advantage, high availability will be available. High availability will be there for our application. No need to redeploy all the APIs when there is one small code change. Okay, there is no single point of failure. If one API is having a problem, but still other APIs will serve the other functionalities. Okay, so there will not be downtime for our application, and burden will be reduced on the server because all the functionalities will not run in one server. Functionalities will be distributed. Functionalities will be running in separate microservices. Every microservice will run in the separate server. Okay, so this is a basic introduction related to software project developers and the DevOps engineers and the testers. Everybody should know this information. This is a common general knowledge that every software engineer should have. Project, why project, what type of projects, what technologies, what is tech stack, what is monolithic, what is microservices. Are you able to follow me? Super. Cool. Next one, guys. We need to understand, software project development life cycle. Then you will understand the purpose of DevOps team. Okay. So what is software development life cycle? That is called SDLC. What is SDLC? Okay. Why people are going to follow this SDLC? SDLC stands for Software Development Life Cycle. SDLC stands for Software Development Life Cycle. Okay, it represents how companies will complete one project. The development life cycle, the process that companies will follow to develop one project. Software development life cycle. It represents how companies will develop software project. The procedure the companies are going to follow to develop the software project is called as software development life cycle. In SDLC, several pages will be available. In SDLC, several pages will be available. So what is the meaning of several pages available in the SDLC? For every project development, first requirements gathering will be available. Company should understand what is client requirement, what client is expecting. Okay, so SDLC nothing but software development lifecycle. It represents how companies will develop one project. In SDLC, several phases will be available. What are those phases? First one is requirements gathering. Company should gather the requirement from the client. Client want one project, guys. Client want one project. So what is client expectation? Company should know that. So that's why first company is going to gather requirements from the client. Then once the requirements are gathered, then company is going to do analysis. Requirements gathering, requirements analysis. So whatever the requirements client is giving, can we develop those requirements or not? Is it possible to develop those requirements or not? So that analysis we are going to do from the company side. Because if a client say that if I click one button in my mobile, a rocket should go to the sky. That's not possible for us. Are you getting my point? Whatever the requirement the client is giving, blindly we can't accept that, right? So we need to analyze the requirements given by the client. So is it possible to develop or not? Is it possible to develop or not? That we are going to analyze. Once that analysis is completed, then a designing will be available. Nothing but planning will be available. Okay, client has given 100 requirements. We have analyzed. Out of 100, 90 requirements we can do, and requirements are not possible. That is analysis part. Once analysis is completed, we will tell to the client, boss, you told to develop these 100 requirements. Out of these 100, 90 are possible. 10 requirements are technically not possible. So if there is any glitch, if there is any risk, then we need to analyze that risk and we need to explain to the client also. Okay. Then design. What is the plan? What is the plan that we are going to follow? What is the planning that we are going to follow to develop that? Once the designing is completed, then project development will be available. Once the design is completed, then project development will be available. Once the development is completed, companies will prefer testing. Okay, once the coding is completed, then we will go for testing. Once the testing is completed, then project deployment will be available. Then project maintenance will be available. Deliver, deployment, and deliver. Deployment and delivery will be available. Then project support, or we can say maintenance will be available. For the project, maintenance will be available. So these are called as SDLC phases. So company is going to follow this process in order to develop a project. Company will collect requirement from the client. Then analysis will be done on the requirements. Then designing will happen. Then designing nothing but planning. Design or plan. So what is the plan to do this? How to complete this? By when we can complete it? What is the risk available? How to mitigate that risk? We are going to discuss and we will design the plan. Okay. Then next one, development will be available. Development means coding. So development team will write the code as per the given requirements. Then testing. Once the coding is completed, testers will be available. They are going to test our code is working as expected or not. Then deployment and delivery will be available. Deployment and delivery will be available. So once the project is delivered to the client, then project maintenance will be available. Once project is delivered to the client, then project maintenance will be available. This maintenance is also called as support. This maintenance is also called as support. Okay. This is SDLC, software development lifecycle. So companies are going to follow SDLC in order to develop the project. SDLC stands for Development Life Cycle. In this development life cycle, several phases are available. Requirements gathering, requirements analysis, design, development, testing, deployment, and maintenance of the project will be available. Now, in SDLC, there are several models available. In the SDLC, we have several models also. In SDLC, we have several models, guys. So the first model that came into market, which is waterfall model. The first model that came into market, which is called waterfall model. And the second one is the spiral model and all available. But current model, which is trending in the market, is agile. So this waterfall model is outdated. Agile model, which is current trend in the market. Coming to the architectures, monolithic architecture got outdated. Microservices architecture is trending. Monolithic architecture got outdated. Microservice architecture is trending. Coming to the SDLC also, coming to the SDLC models also, waterfall model that came into the market initially. Later point of time, people realized that there are some challenges with the waterfall model and people are going with the agile model. The current trend in the market is agile model. Now, let us see some diagram related to waterfall model. Waterfall means from top to bottom. Okay, waterfall model nothing but which is top to bottom. Waterfall model. Now, if you see any image related to waterfall model means top to bottom will be available. Top to bottom will be available. Requirements, planning, execution, testing, deploying, maintenance. And if you see requirements, design, develop, test, deploy, maintenance. So waterfall model means after one stage is completed, then only people will go for the next stage. If one stage is completed, then only people will go for the next stage, that is called waterfall model. That means first we need to collect the requirements. Once the requirements collection is completed, then we need to go for the design. Then once the design is completed, then only we should go for the development. If development completed, then only go for the testing. When we are in the testing phase, client cannot change the requirement. When we are in the testing phase, that means in the waterfall model, we will move only in the forward direction. When we are going for the waterfall model to develop the project, we will move only in the forward direction. That means after one stage completed, then only we will go for the next stage. We cannot come to the previous stage. There is no backward direction. Waterfall model means waterfall is a linear model. Waterfall model is one of the SDLC model that people use to develop software applications. This waterfall model is also called as linear model, or it is called as sequential model. It is linear model. After one stage is completed, after one stage or one phase, after one stage completed, then only we will move for next stage. Then only we will move to next stage. Okay. Now, in the waterfall model, requirements are fixed. Budget is fixed. Requirements are fixed. Duration fixed. Budget is fixed. Budget fixed. Client will see the project at the end. Client will see project at the end only. So this is the problem with the waterfall model. Waterfall model is one of the SDLC model. This waterfall model is called as linear model. So here, after one stage is completed, then only we will move to next stage when we go for waterfall model. So in this waterfall model, requirements are fixed. Client should give the requirements in the initial stage. Based on the requirements only, we will go for the analysis and design and development. So when we are in the development phase, client cannot change the requirement. Once the development completed, we should go for the testing. When we are in the testing, client cannot change the requirement. Company cannot change the budget. So here, requirements are fixed. Duration is fixed. Budget is fixed. and the client will see whole application at the end only. So company has taken the requirements 2 years back. They have designed, developed, tested. Today, they are delivering the project to the client. Today, they are delivering the project to the client. 2 years back, client has given the requirements. Company delivering that project to the client today. But client is not happy. 2 years of time is wasted. Lot of money is wasted. So this is the biggest drawback in the waterfall model. I gave the requirement 2 years back for my business. Today they delivered this project. Whatever I have expected, it is not there. Then can we ask the company to change the requirement? Can we ask the company to redevelop the project? No. Client involvement will be very less in the waterfall model. Client will see the project at the end only. If a client is not satisfied with the delivery of the project, then time is wasted, money also wasted. Time is wasted, money also wasted. Big loss for the client. Because this waterfall is a linear model. In this linear model, after one stage completed, then only we will move to next stage. So here, in this waterfall, requirements are fixed, duration is fixed, budget is fixed, client will see project at the end only. If a client is not happy with the delivery, a big loss for the client because money wasted and time also wasted. If a client don't like the delivery, if client don't like the delivered project, then it's big loss for client because already money wasted and time wasted. So that's why currently in the market, people are not using this waterfall model. Waterfall model is suitable for small applications, not for the big applications. Why? Because if you want to run one business, you have some idea, you gave your ideas to the company. Company told that 3 years time it will take to develop your project. So whatever the requirements you have given 3 years back, today they delivered that project. So with your ideas, whatever the ideas you have 3 years back, will they work out in the today's market? Maybe, may not be. Because new competition is there in the market. Every day new things are coming into the market. Whatever the business plan you have 3 years back, today that may be outdated. Maybe someone already came with the same business 2 years back only. 3 years back, you gave the requirement to one company. After 1 year only, so many people came into market with the same idea. But after 3 years, you have seen your project. So your ideas, what you have at that time, today they don't have any value. They are outdated. So do you like this kind of approach to develop your application, guys? Come on. Do you like this approach to develop your application? No. Okay. So that's why what people are doing now, currently in the market, people are using waterfall only for small scale projects. This is suitable. This is suitable. This is suitable for small scale applications like one school project, Okay, one simple bookstore project. Any simple small scale business applications are there. For them, we can use waterfall model. Okay, but for the enterprise applications, for business applications, we need to go for agile model, which is trending in the market. So currently in the industry, people are using agile model to develop the projects. Waterfall model is outdated because it is suitable for only small scale applications. So that's why currently in the industry for business applications, people are going to use agile model. What is this agile model? What is the benefit with the agile model? Let's discuss that in the tomorrow session. Let's discuss about the agile model in the tomorrow session. Is this fine for everyone? I hope too much theory today. So let's take a break for now and we'll discuss again tomorrow. What is agile? Why we need to go for agile? What is a scrum? What is a sprint? That we will learn in the tomorrow session. Good guys. Thank you.